We're asked to find the derivative of the inverse of f. And since we can't explicitly get the inverse of f, we're going to have to use what our textbook has defined as the derivative of the inverse. So the derivative of an inverse function is the reciprocal of, a better way of saying is 1 over the derivative of the function with the inverse plugged into it. So we need to know what the derivative of f of x is first, because that's what the outermost part of this idea is. 3x squared plus 8x, and then there's no 9 there because we're taking a derivative. So that's what the derivative is. We have this part. And now we need to plug in the inverse at a. Oh, okay. So we don't know what the inverse is, right? We don't have f inverse. But we could get a particular value of the f inverse, okay? Because an inverse says that your x and your y variables are flipped, and your input and your output variables have swapped responsibilities. So when they tell us that they want us to plug in a value into the inverse function, that means this is a y value. This is like a value that would go over here. So a equals 0 means I'm going to plug 0 over here, and I'm going to solve for x. So that's cubic. We can use a. Oh no. Can we factor it? Could probably factor that as a cubic function. It's kind of hard to do though. So solving this equation, you could go to a graphing calculator. The only other way I can think of doing this, because it could be two solutions. Oh, I gotta stop and think about this for a second. When I stopped, I realized, look, I took the derivative wrong here, right? That should be plus 8. Solving this, I guess there's no easy way to do it other than using a graphing calculator, or you could try to factor out a root. You could use the rational zeros theorem, which says that your only possible zeros are a ratio of the leading of the last coefficient and the leading coefficient. So these are all our possible zeros: positive or negative 9, positive negative 3, or positive negative 1. If you try plugging each of those in, you'll see that 9 isn't a 0. Negative 9 also is not a 0, I don't think. Eventually plugging them in again and again, you'll get that negative 1 is a 0 out of that list. If you don't know the rational zeros theorem, you don't have to know it for tests in this course. Go ahead and use a graphing calculator, okay? But if you plug in negative 1, you're going to get negative 9 plus 9 makes 0. So negative 1 would be a solution, okay? And that's what we were looking for here. So look, recap of what we did was we're trying to find out what this value is when a is 0, okay? That means, since this is an inverse function, that means y equals 0. That means we're plugging in 0 over here. It was just a cubic equation to solve for x. And when we did that, we found out that the x variable was negative 1. Negative 1 would make this become a 0. Okay, so when we go through this notation, it's 1 over the derivative. But everywhere where we have an x in the derivative, we're plugging in what we just got out for the inverse. We just got out negative 1. And if you simplify that, that's 1 over 11.